Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 12.3. Problem number 13. In figure, a square OABC is inscribed in a quadrant OPBQ. So here the diagram is given. You see there is a square OABC, right? OABC is a square and OPBQ is a quadrant. OPBQ is a quadrant, right? If OA is 20 centimeter, find the area of the shaded region. So here the side of the square is given, right? We have to find this region. So here the basic thing is you have to calculate you see obviously this is a quadrant and this is a sector as well, right? Because there are two equal lengths and the corresponding length. So first step is you have to find the area of this sector. Then you have to subtract area of the square from it. Then you can easily calculate the area of the shaded region. But here the twist here is, you see, we are given only this length. That is OA is given, but what we actually need, we need the length OP. Right. So here as a first step, I start with finding the area of the square and then we will proceed gradually, right? So area of the square is nothing but area of the square OABC, even you can write that also, right? OABC is equal to A square, so which is equal to 20 into 20, that is 400 centimeters square. Now you see, as we need this length, right, that is the radius of this sector. So here how to calculate that? So to calculate the radius of the sector, you see here we are going to find the diagonal of the square, right? So what is the diagonal of the square here? You see, this is one diagonal and this is another diagonal, right? So here why we are calculating the diagonal? Because again this forms the radius, right? Because it connects the center to a point on the circumference, right? So this is the radius of the respective sector. So what is the formula to calculate the diagonal of the square? So here it is nothing but A into root 2. The value of A is 20. So here it is 20 root 2 centimeter. So this diagonal of the square, it is nothing but it is the radius of the sector OPBQ. So therefore the radius of the sector is 20 root 2 centimeter, right? So next we are going to find the area of the sector. So area of the sector is given by the formula theta by 360 into pi r square. So from this diagram, you see, just consider this sector part alone, right? So what about the angle here? It is a perfect L shape, right? Therefore the angle here is 90 degree. So substitute the value of theta as 90. So 90 by 360 into the value of pi, 22 by 7. What about the radius? You see the radius of the sector is nothing but it is the diagonal of the square. Therefore here you have to substitute 20 root 2. So since it is r square, you see 20 root 2 the whole square. So 20 square is written as 20 into 20 and root 2 the whole square becomes 2. Right. So when you cancel the common terms, finally we are ending up with the answer as 4400 by 7 centimeter square. Because here the length of the side is given in centimeter. That's the reason why here we are writing centimeter. Right. So always make a note of the units. So since it is area, it is square here. The next is area of the shaded region. Right. So area of the shaded region is nothing but, as we already said, that is, you have to find the area of the sector, you have to find the area of the square. When you subtract area of the square from the area of the sector, then we will be getting the area of the shaded region, right? So here, area of the shaded region is area of the sector minus area of the square. So area of the sector is 4400 by 7 minus area of the square is 400, right? Again, when you take LCM, and when you subtract, we are getting 1600 by 7, and when you solve this here, our answer is 228.57 centimeter square. Right. Our next problem is problem number 14. AB and CD are respectively arcs of two concentric circles of radii 21 centimeter and 7 centimeter and center O. So here you see we are having arcs of two concentric circles, and that too you see everything, the diagram is given clearly, right? So here once you look at the diagram, it will be very easier rather than reading and understanding this problem, right? So this is the given diagram and you need to find the area of the shadowed region. What are all the given parameters? You see here they have clearly mentioned, right? AB and CD are respectively arcs of two concentric circles. So here this is an arc and this is an arc, and the respective radii you see it is 21 centimeter and 7 centimeter, that is length of this arc. Okay, the bigger arc is 21 and the smaller arc is 7 and the angle is 30. So here how to calculate the area of this shaded part? Obviously you see these two are sectors, right? Because we are having two radii and the enclosed path. Similarly here we are having two radii and the enclosed path. So here the step is you have to find the area of the bigger sector, right? Then you have to calculate the area of the smaller sector. Finally, you have to subtract the area of the smaller sector from the area of the bigger sector here, right? So area of the sector OAB, this is given by theta by 360 degree into pi r2 square. Since here we are having two radius, I am mentioning it as r2 and r1. So you better write it as let r1 is equal to 7 centimeter and r2 is equal to 21 centimeter, right? So here theta by 360 into pi r2 square minus again for this small sector theta by 360 into pi r1 square, right? So we know the value of theta, right? It is given as 30 degrees. So just substitute the values here, right? So after substituting the value, you see theta is 30 and pi is 22 by 7, right? The value of r2 is 21 and r1 is 7. So when you take the common terms outside, the remaining terms are 21 square minus 7 square, right? So here whenever you are having numbers like this, right, it is up to you to calculate 21 square and subtract from, and you can subtract the 7 square from this answer. But here I had done in this way, that is this is of the formula a square minus b square, right? So this can be written as a plus b into a minus b. So what is the value of a? It is 21, b it is 7. So when you substitute, you see here I am ending up with 28 and 14, which makes the calculation pretty simpler, right? So here again when you cancel the common terms, okay, you see 0 0 cancel, 3 and 36 by 12 times, right? And again 12 and 22 are cancelled by 2. So here it is 6 and here it is 11. So 1 by 6 into 11 by 7 into, here the answer is 28 and 21 minus 7 gives 14, and again we can cancel the common terms, right? 7 and 28 cancel by 4 times, right? So again here we are having the 6 and 14, they cancel by 2. So finally here I am ending up with the answer as 308 by 3 centimeter square, right? So that's all. If you have any doubt, let me know in the comment section. Thank you.